Okay, so last topic for today, we're going to look at combining these functions and trying to do some simplifications once they're combined together. So here's your first way the functions could be combined. Either you have both sines or both cosines or both tangents when you combine them up. And when you're doing it, you can get some automatic cancellations, meaning the sine and the sine inverse automatically cancel each other out. The answer is whatever's here. But the only time that those automatic cancellations happen is if you're in the correct interval. The interval comes from looking at the outside function. So if you're looking at the sine function, what you need to do is check the range of that outside function. So here, the range for sine is -1 to 1. That means if the number on the inside is any number between -1 and 1, they automatically cancel. For a sine inverse, you need to look along its range, which is the same as the restricted domain. So you need to be between -pi/2 and pi/2. What's the range of cosine? Cosine. Well, I better draw a better cosine graph. What's the range? -1 to 1. The restricted domain, this is the range, -1 to 1. The restricted domain was 0 to pi, and the restricted domain becomes the range of the inverse. So for the inverse function, you need to be between 0 and pi. If you're looking at the tangent, the range is any real number. The restricted domain ran from this asymptote to this asymptote. And that restricted domain becomes the range of the inverse. So the range of tan inverse is -pi/2 to pi/2. In my head, I picture a unit circle. Now this, what I'm going to tell you, is only for your inverses. And I'm going to add to this next class. But I picture a unit circle, and I draw arrows here. And so far, that's a cosine. We'll add more to it next class. And then I draw arrows here. And so far, that's a sine and a tangent. And we'll add more to it. But it helps you match up which ones have the same types of restrictions in the domains. Sine and tangent are the same restrictions, except on a tangent you can't include the pi/2s. So here's some examples, and either they're going to automatically be able to cancel out and the inner function will be the answer, or they won't and you'll have to do some kind of adjustment to get your answer. So I'm wondering if sine inverse and sine can automatically cancel and that the answer would be pi/8. This is what I'm trying to figure out. To know if that can happen, I have to check the range of sine inverse. And sine inverse is the one that runs like this. It can go from -pi/2 to pi/2. So the question is pi/8 a number in here between these two numbers? If you're good with fractions, you see that it is, so you know that this works and that's your answer. If you're bad with fractions or a little bit nervous, here's how you could figure it out. Turn this into a denominator 8. So this is 4pi/8. And turn this into a denominator 8. So you know it takes 1, 2, 3, 4 tick marks to hit the top, and then it takes 1, 2, 3, 4 tick marks to hit the bottom one, And if you're looking for pi over 8, that's one of those tick marks. And yes, it was between the negative pi over 2 and positive pi over 2. That's just if you're not comfortable with fractions. Okay, next one. Again, we're wondering, can the inverse and the sine cancel out? And the answer just be 6 pi over 5. We don't know yet. That's what we're wondering. So we set it up the same way. Sine inverse has to be between negative pi over 2 and pi over 2. And I knew to pick that for the restrictions because it's always restrictions on the outer function. So restrictions on the sine inverse. Now, depending on how you are with your fractions, you may or may not be able to see if it's between these two intervals. If you're doing fractions, you want to get a common denominator for the 5 and the 2. So common denominator would be 10. And then same thing down here, negative 5 pi over 10. So it takes 1, 2, 3, 4, 5 of the pi over 10 tick marks to hit this spot. And then going the other way, it takes 1, 2, 3, 4, 5 of the pi over 10 tick marks to go in a negative direction. Now the question is how many of those tick marks, and basically you know there's 4 tick marks per quadrant. So the question is 6 pi over 5 would be equivalent to how many of the 10 tick marks? 12 pi over 10. So let's count them out. Okay, so counting out 12 of the tick marks, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tick marks. So we're definitely not in the correct interval. But the main idea is where could you get this y height? That's what we really need to figure out. And that's not the only location where that y height occurs. From the x-axis, if you travel down 2 tick marks, you get to that y height. So come over here. From the x-axis, if you travel down 2 tick marks, you'll also get the same y height. So you need to travel down down by 2 of the pi over 10 tick marks. And that will take you to this angle with the exact same y height that you needed, which is
negative 2 pi over 10.
Yeah, negative 2 of the pi over 10 tick marks. And that will take you to the same y height that you needed, so that would be negative pi over 5 for your answer there. Those answers have to be in the correct domain. Any questions on that one? Okay, let's try another one. This time your outer function is a sine, and the range of sine is negative 1 to 1. With these, you often don't need the picture as much because it's easier to tell if 2/7 is a number between negative 1 and 1. Yeah, so the answer is 2/7. If you're not good with fractions, you could think of it as negative 7 over 7, negative 1, and 7 over 7, positive 1. 2 over 7 would be in this interval. Here's a few more. Again, the outer function is a sine, so you need to be between negative 1 and 1. Is 0.5 a number between negative 1 and 1? Yes, so the answer is 0.5. Outer function's a sine. You need to be between negative 1 and 1. Is 0.8 a number in that interval? Is 1.8 a number in that interval? No. So here the answer does not exist.
So, but this one you don't have to do any.
Right. When the outer function does not have an inverse on it, You just say it exists or it doesn't. When the outer function has an inverse on it, that's when you may need to do some swapping around and counting tick marks. Same idea with the cosines. Outer function's a cosine. Cosine has to be between -1 and 1 for its range. Is 0.2 a number between -1 and 1? Yes. So the answer is 0.2. Outer function's a cosine. Cosine has a range of -1 to 1. Is 2.5 a number in that interval? No. So the answer does not exist. They're easier when the outer function's not an inverse. Okay, here's some more with the cosines. And all three of these, the outer function is an inverse. So for all three, and I'm looking here, the outer function is an inverse. So for all three, you need an inner value somewhere between 0 and pi. And I'm referring to these numbers. Need to be numbers between 0 and pi. Okay, so for the first one, we need to be in here, 0 to pi. We're at 5 pi over 6, so that's 1, 2, 3, 4, 5 pi over 6 right here. That is between 0 and pi, so that's the answer. If you're looking at the next one, 5 pi over 4. Let's see, we're counting pi over 4 tick marks. We need 5 of them. So 1, 2, 3, 4, 5. Not in the correct interval. Cosine's an x distance. So you need another angle that could give you that same x distance. So can you see how many to travel? 1, 2, 3. Yep. Make sense? Okay, let's see. 5 pi over 7. Need to be between 0 and pi. We may not have the 7s memorized, so why don't we turn pi into a denominator 7? That's 7 pi over 7. And then you could definitely see 5 pi over 7 is in there, right? So for this one, you already know the answer. But just to carry it a little bit farther in case you needed it, if this was pi over 2, you could turn it into a common denominator of 14. And then you'd know it takes 6 tick marks in a quadrant, and then the 7th one to hit that. And then again 6. And then you could count out to 5 of them. So let's see. Actually, you need to turn this into a denominator of 14 also. And then you know you need 10 of the pi over 14 tick marks. And you could count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you would know you're definitely in the correct interval. Okay, last style. We've got the tangents and the tan inverses. The range of the tangent is all reals. So as long as this number's a real number, not imaginary, that's the answer. Is 1 a real number? Yes. So the answer is 1. Outer function's tangent, is pi over 10 a real number? Don't see an I attached to it. So it's pi over 10. For the inverses, you need to be somewhere between negative pi over 2 and pi over 2, but not inclusive. Okay, so if we're trying to line this one up, it needs to be between negative pi over 2 and pi over 2. The denominator here is 13, so I'm going to switch to a common denominator of 26. So it takes 12 tick marks in the quadrant, but you can't hardly draw, and then the 13th one is right there. So it takes 13 of the pi over 26 tick marks to hit this spot. It's a lot. And then 2 pi over 13, if you were to switch that to a denominator 26, you need 4 of them. And definitely, you're still in the correct interval. So this one is still negative 2 pi over 13. Okay, and the last one, again, tan inverse, so it needs to be somewhere between negative pi over 2 and pi over 2. This time we're looking at the angle 4 pi over 5. And let's get a common denominator of 10. And so now you know it takes 4 tick marks, 1, 2, 3, 4, to hit that 5th pi over 10 tick mark that's up here. So 4 tick marks in every quadrant. Okay, now 4 pi over 5, we want to go ahead and write as a denominator 10. So that's 8 pi over 10. So we need 8 tick marks. That's 1, 2, 3, 4, 5, 6, 7, 8, which takes us to the wrong quadrant. The tangents are kind of funny, the way you work those out. What you basically do is you add pi. Or you may need to subtract it. I'll say add or subtract pi to move into the correct quadrant, because tangents are off by pi's. Or the way you could do is count your tick marks. This is 2 tick marks above, so you need to travel 2 tick marks below, and the tick marks were size pi over 10s. So it's 2 of the pi over 10 tick marks in a negative direction. Negative pi over 5. Or the other thing you could have done was take your 4 pi over 5 and then subtract pi. If you do 4 pi over 5 minus pi, that'll take you over here to the negative pi over 5 that you needed to be at. So either way, just add or subtract pi or just count your tick marks.